Hi, welcome to section 10.3, which is actually pretty much the end of chapter 10. What we're going to look at today is the inverse of a matrix as well as the identity matrix. These can be used to actually solve systems of equations using matrices, but in terms of doing it by hand, it's a lot of extra work, so it's really not recommended. Augmented matrices do the job much, much better than inverse matrices do. But I think they are still interesting things for us to look at for this chapter. So an identity matrix is that thing that we've actually been building inside of our augmented matrices. However, it doesn't have that extra little thing on the end. It is just the diagonal of ones, and then everything else is zero. Diagonal of ones, everybody else is zero. And we note them with this I and then a little sub number. These are always going to be square matrices, so we don't need to say it's going to be a 4 by 4 or a 3 by 3. If we say identity size 3, we can assume that it's going to be a square matrix, and so we know what the other number is going to be. Some cool things about multiplying them is they don't do anything. It's kind of like a multiplying by 1, but matrices, we don't really have numbers. If we want to do a multiply that doesn't change a matrix, we can use an identity matrix. So I'm just going to do that quick just to make sure my thing doesn't crash. So if I made an identity matrix that's 2 by 2, so 1, 0, 0, 1, that's what it's looking for right there. If I multiplied that by matrix A, this shouldn't do anything. So we get negative 2, 4, 1, 3, 7, negative 1. So let's find out. I have over here a 2 by 2, and then this one is a 2 by 3. So my resulting matrix, these are the same, so I can multiply. My resulting matrix should be 2 by 3. So that's starting to look good, that it's not going to change. So all right. So I need to do the first row times the first column to find that first spot. So that's negative 2 plus 0 times 3 is 0. So it's just going to be negative 2. So negative 2 plus 0. And then I want to do this 1 and 0, the 4 and the 7. I'm going to move across the top. So that is 4 plus 0, and that's still 7. And then we do this again times that one. So that's 1 times 1, which is 1, plus 0. So that is still 1. Why did I write this as a 7? I don't know. Let's do the bottom row then. So in the bottom row, we got 1 times 0 times 1 and 0. Why do I multiply those things? 0 times negative 2 is 0 plus 3, so that's a 3. And then this part times that part, that is 0 plus 7, so that's 7. And wouldn't you know it, we end up with the same thing that we started with. So that's kind of proving that, if you multiply by your identity, you're not going to change the values in that matrix. Now we can get the identity if we multiply by the other thing that we're talking about today, which is the inverse. So I have these two matrices, and I'm telling you right now that these two are inverses. But how would you believe me? Well, what should happen is if we multiply A and A inverse, we should get an identity matrix. And since they're both 2 by 2s, we should get an identity matrix of size 2. If we don't, then they're not inverses. So let's try it out. So we have 1, 3, 2, 5. We're going to multiply that by the other matrix, negative 5, 3, 2, negative 1. We got a 2 by 2 and a 2 by 2. So the 2's match up, and we're going to end up with a 2 by 2. So we're looking pretty good so far. All right, so we've got 1 and 3, and this one, so that's negative 5 plus 6. Then 1 and 3 and these two. So that's 3 plus -3. We move on to the next row and this column, we get -10 plus 10. And the second row and the second column will be 6 minus 5. And then if we combine all those numbers, -5 plus 6 is 1, 3 plus -3 is 0, and then we get a 0 and a 1. Aha, that's an identity matrix. So yep, that is those two matrices are inverses of each other. Neat, neat, neat. Well, that's a cool thing. How do I find said cool thing? Well, that's what this thing is. Here's how we do it.